Alright, so I've graphed out a couple of different histograms here. And I wanted to talk about describing your data. We'll use some words like, we'll talk about the center and the spread and the shape of your data. We'll talk about outliers and skewness. We'll talk about the modes, like unimodal and bimodal and multimodal. And we'll look at just a couple of different graphs here. So looking at this first one up here in the top left, this data here is spread out quite a bit. I would expect the range to be substantially large compared to maybe looking at the range down here. Notice that they're further apart versus this one here. Of course, I'm ignoring this little point over here. We'll talk about that in a little bit. But the main thing you notice about this graph is that, let's say you were to draw a curve that fit it, that curve is going to tail off to the right. So your data here kind of falls off to the right. If you're thinking in terms of lines, you might say that the slope is decreasing. So we talk about the shape of this data here. We say that it's skewed, and it's skewed to the right. It's skewed in the direction of wherever the tail of the data is, wherever that small amount of data is. So most of our data is over here on the left side, but we call that skewed to the right, versus something that is more like this one here. Here the shape, if you were to draw it, looks a lot more symmetric. So we would call this data here symmetric. That's just talking about the shape for now. You would also talk about the number of peaks that your graph has. So for example, both of these have one peak that is higher than all the others. So they would both be examples of unimodal data. Unimodal. Uni meaning one, like a unicycle has one wheel. Modal meaning one mode. So it has one mode, one bar that is the most common or the most frequent. This measures the frequency of your data. So notice the next graph down here has two modes. So that data we would call bimodal. Bi meaning two. So bimodal data. So these two here were unimodal. This one's bimodal. So if you were to draw a curve around it, you would see kind of like a camel sometimes has two humps. You'd have two humps. So this one is bimodal, and it's also, the humps are pretty symmetric. So you'd say it's bimodal and symmetric data. Something that's really important, when we start talking about the center, bimodal data tends to behave differently. So we'll talk about some examples of that here in just a second. Notice this graph here, there's not really one clear peak that has the most in it. So this would be an example of multimodal data. And I would say that it's also symmetric. You wouldn't really want to draw a curve around it, but notice if you were to fold it in half, you'd get about the same thing on both sides. So then this one here, you should probably be able to figure out what this one is. It looks pretty much like a mirrored image of one of the ones you've already talked about. So if we go back up here, this one was skewed to the right. So this one here would be skewed to the left, because the tail kind of tails off to the left side. Something like that. So all of these graphs were pretty well spread out. We would say that their spread is quite large. In order to determine the spread, all we've talked about so far is range. So you might say that the range would be whatever the top value is minus this value here. So your range would be this many units long, or this many units wide. This range would be this many units wide. So notice that this one here is the most spread out of the 4 or 5 if you count this one. And then looking here, if you exclude this here is called an outlier when it's a piece of data that doesn't really fit with the rest of your data. If you were to exclude the outlier here, this would have the smallest spread or the least variability. The numbers here are not very far apart. So this graph here looks pretty symmetric to me. Again, you do have something out here called an outlier, which is a piece of data that doesn't quite fit. It's like the black sheep of your data set. So one thing that we can talk about outliers. We'll talk about the shape. Is it symmetric or unimodal or skewed or bimodal or multimodal? But the main thing you're probably going to be looking for is your center. Where is the center of your data? Where's the meat or the most important part of your data at? And usually to find that for data that's not categorical, like for example your favorite color, you're not going to use the same thing you'd use to measure like for example the weights of people in a classroom or the heights of people in a classroom. Those are two different types of data. But for data that is numerical, we'll say, you would want to use either the mean, the average, or you want to use the median, the middle of your data. And it kind of depends on the shape of your graph on which one you use. You can kind of recognize if you have trouble seeing that something is skewed, looking at the mean and the median can help you figure it out. Because something happens when you have a skewness in your data. So for example, on this graph here, the middle of our data, the median, maybe a different color here, the median would probably be somewhere around in here, roughly. I don't know what the data is, so it makes it a little bit harder to compute. But the middle of it, notice I have more data over here versus fewer over here, so I'd expect it to be closer to this side. But somewhere in the middle of your data. It's not the exact center of this range. It's thinking about you have frequencies. These heights represent frequencies. So where would the middle frequency be? It'd be somewhere maybe around in this column here. So think about what the mean is going to be. So we don't have very many of them, but we have numbers out here that are much, much bigger than the numbers to the left of the median. So think about when you're averaging in your test grades. Let's say your average is a 50 right now, and your median is also a 50. So your grades are pretty symmetric. Maybe you have a 40, a 50, and a 60. So your median and your average would both be a 50. And then let's say you throw in 100 average into that. That's going to bring your average up quite a bit. It'll bring it up about 25 points actually. Versus your median would only shift up to 55. So there's a really big difference there. So whenever you have even small, you don't have very much of it, your frequency is very small here. But the numbers themselves are much larger. They have a larger value than numbers over here. So that's going to pull your average up. So your average here, your X bar we've talked about, would be larger than your median. So I would probably be inclined to use the median for this data set because it's much, much closer. Maybe your average would be right around in here. Your median is closer to the most important set or the most part of your data there. Versus if it's skewed to the left, well, you've got you don't have very many of them, but you've got numbers down here that are much, much smaller than numbers over here. So maybe the middle of your data might be in this column, but your average would be closer to the left because these numbers here are pulling those numbers down. So here your average, your X bar, would be less than the median. So again, I'd be more inclined to use the median when your data is skewed. However, for symmetric data, you're probably going to want to use your average or your mean almost every single time. So just like we looked at for skewness, you don't want to probably use the average because it's going to be affected by those smaller values. Whenever you have an outlier, you definitely don't want to use the average. So you definitely want to use median anytime you have an outlier. And you'll probably want to use it when it's skewed also. For multimodal data, again, this is very symmetric data here. You'd again want to probably look at the average, or your X bar, your mean. And bimodal, I said that was a special data set. What you're really going to want to do here, if you want to get an honest idea of your median or your mean, I mean, if you figure them out, since it's symmetric, both the mean and the median is going to be right in here. And as you can see from looking at those numbers, most of your data is not in this section here. It's over here. So one good example to help you understand this is if you're measuring the heights of people in the classroom, your first hump here is probably going to be the height of the girls, because usually girls are not as tall as boys. And then this height might be the average height of the boys. So what you really want to do when you have bimodal data is you want to split it apart into two different curves. And then look at the average of either one of those, or of both of those curves, and that would be your median. So or that would be your measure of center. So we might have a girl's curve that looks like this, and we'd use the average there, and the boy's curve looks like this. So you want to separate the data whenever it's bimodal. And that's usually the case. If your data isn't bimodal, like if it's not looking at two different categories, then you probably just need to adjust your class width so that these two humps come together, and then you can have a better idea of whether you want the mean or the median. So I said I'd give you some examples of things that are skewed and symmetric and bimodal. So I already said bimodal, that would be like heights in a classroom. Something that's symmetric, maybe if you were looking at the weight of 7th grade boys. You would expect, since they're all 7th grade boys, their weights would be around the same area. It'd be symmetric. You'd have just as many that are really skinny versus really large, and most of your kids would be average, you would anticipate. Multimodal data like this, where all the peaks kind of come out to be the same, or here you're looking at something that's called a plateau, because it's kind of flat across the top. That's something where you have a random chance of it happening. So like we talked about for heights here, all of our heights fall in a range from maybe 5 foot to 6'3" in high school. Here, this might be like, let's say you've got a 20-sided die and you're rolling it like 500 times and writing down the number that comes up. Each of those numbers has an equal chance of showing up. So all of the numbers have the same frequency, just about, if you did it, let's say, 5,000 times. Or maybe looking at phone numbers from all over the United States and seeing how often each digit occurs. So that would be something that's multimodal, something that's kind of got a plateau across the top. Skewness, for example, something that's skewed to the left, a really good example there is GPAs. If you look at your GPA, if you think about in high school, most students are not down here failing every single class. Their average GPA is actually a lot closer to 3.0, especially for seniors and juniors. Maybe 2.8 or 2.7 if you're a sophomore or freshman. So your GPA is actually skewed to the left. Most of them are pretty high. Generally we pass all of our classes. Something that's skewed to the right might be like salaries at a company like McDonald's. Most of your employees do not make a lot of money, but then you've got some people that have been there for a while, and so their salaries start to increase. And for that example there, you'll probably have, way out here, you'll have an outlier for your general manager that makes a lot more than everybody else. So those are some examples of types of graphs that you might come across, and I try to give you some real life examples for applying them. And hopefully you understand all the vocabulary words, when to use mean versus median, bimodal and unimodal and multimodal. Talked about symmetric versus skewed to the right or to the left, and outliers. Hopefully you understand all those words. If you don't, just watch the video again or come ask me some questions. I'd be happy to help you. Alright, so hopefully that helps. Just keep studying. Thanks.